All right, here's our problem set. It says compare the pairs of fractions by reasoning about the size of the units. Use greater than, less than, or equal to. So I've got 1/4 and 1/5. All right, so when I'm using my new units, and I just got one of them, I know fourths are larger than fifths. The more I cut something up, the less I have. That's bigger, the size of the piece decreases. So 1/4 is greater than 1/5. Try this one. How about 3/4 and 3/5? Okay, that'd be the same exact thing. Now I'm dealing with the same sizes I dealt with over here, except I have more of them. So I've got 3 big pieces and 3 smaller pieces. This is still going to remain the same. Okay. How about over here? 1/10, 1/12. Well, the more I cut something up, the smaller the size is, smaller size of the piece. So I've got 1/10 would be, again, greater than 1/12. Over here, it's the same thing, tenths and twelfths. I know twelfths are smaller pieces. So if I'm dealing with the same amount of each piece, tenths is still the larger piece. All right? That's what we're meaning by reasoning about the number of the size of the units, okay? All right, down here, I've got the same thing. Let's see here. I've got compare by reasoning about the following pairs of fractions with the same or related numerators. Use greater than, less than, or equal to. Explain your thinking using words, pictures, or numbers. Okay, problem 2B has been done for you. Okay, so here's 2B. It's weird that they did 2B and not 2A. 2/5 is less than 4/9. And they reasoned it by doing this because 2/5 is equal to 4/10. 4/10 is less than 4/9 because tenths are smaller than ninths. That's fine. I would have chosen use the cross multiplication there. All right. Let's take a look back at A. Let me zoom in on that so we can have a closer look. All right. I notice my numerators are the same, 3 and 3. Great. When that happens, like all I have to do is look at my denominators, and I see my denominators are different, and that's fine. Now, if I'm dealing with the same amount of each of these, I know that fourths are larger pieces than fifths, okay? Because the more I cut something up in the denominator, the smaller the piece. So I know that 3 of a small piece is going to be less than 3 of a larger piece, okay? So 3/5 is less than 3/4. Let's take a look down here, and this is going to be the same. See how I'm dealing with 11ths and 13ths? Okay, 13ths are smaller sized pieces. The more I cut something up, the smaller the piece. So if my numerators are the same exact size, I know that 7 larger pieces is going to be bigger than 7 smaller pieces. 7/11ths is greater than 7/13ths. All right, now here's this one. And this one seems a little bit more difficult to solve. And let's take a look and see how we can do this. Now, I know if I just double this here, I can get the same number of numerators on the top, right? I could end up with saying, well, if I multiply both these by 2, I could end up with 12/14ths. And I know that 14ths is a bigger piece than 15ths. And if I have 12 of each, I know that would be greater, okay? Does that make sense? All right. What I could also do is cross multiply. I could start here at the 7 and say 7 times 12, right? That would be 70 plus 14 would be 84. And then I could do 15 times 6. It'd be 60 plus 30 would be 80. All right? Does that make sense? Yeah. It'd be 80. So I've got, let's see, this is 70, 84, good. 15, 60, 60 plus 30 is not 80, it's 90. So I'm going crazy here. 90 is larger than 84, and I'm good. Okay, good. All right, let's take a look at the back here. Now this is what we're gonna do for this. This says, draw 2 tape diagrams, or 2 bar models here, all right, to relate these fractions. So we're gonna do that, okay? This is how it's gonna look. I have 2/3 and 5/6. I'm going to show you what I'm going to do it this way. 2 rectangles, exact same size, one above the other. Okay? Thirds. First one's going to be 2/3. Let's show what 2/3 looks like. I cut it here and I cut it here. and I shade in 2/3. Okay, now sixths. Sixths is a related fact to thirds. So I'm going to cut this bottom one of the thirds as well, and then cut each of those in half to make sixths. See how that works? 1, 2, 3, 4, 5, 6. I have 5 of those shaded in, so this would be 5/6. 1, 2, 3, 4, 5. I can see that this is more than that, right? It really matters that I make my rectangles the same size here. So 2/3 is less than 5/6. Okay? Let's try this one. 3/4 and 7/8. So I'm going to make 2 rectangles the exact same size. Okay? First one I'm going to make 3/4. So I'm going to cut this into fourths down the middle. There. And shade in 3. This one I'm going to make into eighths. So again, I'm going to draw this. These are related facts. So down the middle, half and half. You notice that I cut this one in the fourths again, right? And these lines are perfectly lined up. Now I'm going to cut each of these in half to make eighths. See that? 1, 2, 3, 4, 5, 6, 7, 8. Then I shade in 7 of those. Yep, just a bit taller, isn't it? A bit bigger. 3/4 is less than 7/8. Let's check out this one. All right, this is 1 3/4 and 1 7/12. Okay, if I draw this out, all right, it would look like this. There's 1 3/4. So here's my 1, and here's my 3/4. See how that works? Then over here, I'm going to do the same. It's 1 7/12. So here's my 1, same size rectangle, and here's my 7/12. Same size rectangle. Now 12ths. So this is split into fourths, and fourths and 12ths are related facts, right? So what I have to do is cut that down the side. Now I need 6 pieces here and 6 pieces here, right? So in order to do that, I need to do 5 and 5. So what's this going to look like? 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh, I messed that up. So it happens sometimes. I messed it up. I need to make 5 cuts on that side. It'll be small pieces. 1, 2, 3, 4, 5. And over here, same thing. 1, 2, 3, 4, 5. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's 7 of those shaded in. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm seeing 1 7/12 is less than 1 3/4. So 1 3/4 is greater than. See that? How that works? Okay. So you can draw pictures. And then the final page is right here. Zoom back out again. There. Draw one number line to model each pair of fractions with related denominators. Use greater than, less than, or equal to compare. All right, I could do a number line on this, or I can just change my fractions, or I could do cross multiplication. So here, I'm going to change my denominators. See how this is thirds and that's sixths? I can just make them both sixths by multiplying this one by 2, right? 2 times 2 is 4, 2 times 3 is 6. 4 6 and 5 6. 5 6 is definitely more. So 4 6 is less than 5 6. See here, eighths and fourths? Those related facts. I can change both of these to eighths by just multiplying these by 2. That's going to end up with 2 eighths, I'm sorry. And I know that 3 eighths is greater than 2 eighths, Okay, and down here, check this one out. 2/6 and 5/12. I'm just going to change both these denominators to 12ths by multiplying these by 2. So I end up with 4/12 and 5/12. Right? 4/12 is less than 5/12. And then finally, this one is 8/9 and 2/3. I'm going to change this one to 9ths by multiplying it by 3. So just multiply the numerator and denominator by 3 to make this 9ths. So I end up with 6/9. And I can tell that 8/9 is more than 6/9. There we go. All right, now let's take a look here. This bottom one, we're going to use cross multiplication on to see how we do, okay? And I really want you to get good at it. So teachers, if you want to pause here and explain a little bit on the board, or watch this and go ahead, or then have the kids just do these on their own, don't play the video after, that's up to you. So I'm going to just do them, and teachers, you can pause or do whatever you'd like to work yourself through this. So cross multiplication. We start here and we cross up this way. So 4 times 3 is 12. So this side of the equation has 12. Then I do 7 times 3 is 21. This side of the equation has 21. So all you have to do is ask yourself, which is greater, 21 or 12? 21 is greater, right? 3/4 is more than 3/7. And I know that because 3/4 is more than half. 3/7 is less than half, right? Let's take a look at B. 4/5 and 8/12. All right, this one could be a little bit tougher, all right? So let's check it out. 5 times 8 is 40. 12 times 4 is 48. 48 is more than 40. All right, let's check out this one. 7/10 and 3/5. Let's try cross multiplication. 10 times 3 is 30. 5 times 7 is 35. 35 is greater than 30. How about this one? 2/3 and 11/15. Tough one. 3 times 11 is 33. 15 times 2 is 30. Well, that one's really close. 30 is less than 33. 3/4 and 11/12. All right, I know this one. 4 times 11 is 44. 12 times 3 is 36. 36 is less than 44, so 3/4 is less than 11/12. Plus, you look here, 11/12 is only missing one little small piece. 7/3 and 7/4. Oh, you see how my numerators are the same? So that means which piece is bigger down here, thirds or fourths? Thirds are bigger, right? 7/3 is greater than 7/4. And watch, 3 times 7, 21. 4 times 7, 28. See? All right, 1 and 1/3, 1 and 2/9. So we have 1, right? So they just cancel each other out. Now I have to ask myself, is 1/3 or 2/9 larger? Well, let's check. Let's just multiply the fractions here. 3 times 2 is 6. 9 times 1 is 9, right? 1 and 1/3 is greater than 1 and 2/9. Okay? Let's check out that. 1 and 2/3, 1 and 4/7. Tough. So the ones cancel each other out. So 3 times 4 is 12. 7 times 2 is 14. Wow, really close. 1 and 2/3 is greater than 1 and 4/7. All right, kids, that's it. Tomorrow, you take your math examination for the state. With all the review you've been doing and all the hard work you've been doing on these fractions and the shape attributes, I am sure you're going to do just wonderfully tomorrow. Just take your time, do your best, and we're going to be proud of you regardless, okay? So, good luck tomorrow. Nice job today. We will see you not tomorrow, but the day after, all right? Have a good night, kids.